Okay, guys, let's take a look today at 4.2. This is solving systems by substitution. So second method we're going to talk about, we looked the other day at graphing to solve that point of intersection. And after today, we're going to be able to solve using substitution by replacing a variable with an expression. So you'll see what that looks like here. Look at example number 1. The way we're going to do this, there we go, this is already solved for y. I see y equals 6x plus 7. So I will just take this quantity, which is equal to y, and in the second equation, where I see y, I'm going to go ahead and replace it. Since this is equivalent to y, where I see y, I can rewrite it. So let's do that. So I have 3 times x minus 8 times y, but instead of writing y, I'm substituting 6x plus 7. So now I only have a single variable, x, inside this equation. So let's go ahead and we'll distribute that through. So I have 3x, I have negative 8 times 6x, so that's negative 48x, and then negative 8 times 7, so that's negative 56. Then we'll start bringing our like terms together. 3x's minus 48x's is minus 45x's. And then we'll add 56 to each side. So I get negative 45x equals 56 plus 4, that's 60. And then we divide both sides by negative 45. So x is equal to, and 60 over negative 45, that's a negative. 15 goes in the bowl, so we could reduce. 15 is going to go into 60 4 times, and into 45 3 times. That's going to be 4/3. So now I've just found my value of x. So I can take this and I can substitute it back into one of these to find y. I'm going to pick the first one because I can just put it right in here for x, and then I will know y. If I use the second, that's fine, but I'm going to have to do some rearranging to solve for y. So let's go ahead and take this, and we'll plug it back up into that first equation. So y equals 6 times x, but now we know x is negative 4/3 plus 7. So 6 times negative 4 is negative 24, and those over 3 or thirds. And negative 24 divided by 3, that's going to be negative 8. And negative 8 plus 7 is negative 1. So y equals negative 1. So then the answer to this, the solution to this system, is an x value of negative 4/3 and the y output value of negative 1. So if you go back to what we were talking about in 4.1 and related this, if I graph this line and I graph this line, this would be the point of which they would coincide or exist together, of where they would intersect. Okay, so we're essentially doing the same thing, but we're applying a different technique to find it. So instead of putting them on a graph, now we're using a substitution method to find where that point of intersection would be. So let's look at number 2. Okay, so again, this one's already solved for x, so I'm going to go ahead and I'm going to take this quantity, which is equal to x, and then down here where I see x, I'm going to replace it. I'm going to substitute it. So now I have x plus y, but instead of x, I'm writing y plus 6 plus y equals 10. So I took this and replaced it with what x equaled. So y plus 6 plus y equals 10. That's going to be 2y's plus 6 equals 10. Then I subtract the 6 from each side. So 2y equals 4. Divide by 2. And y equals 2. So now I have the value for y. So I'm going to take that and substitute it back in. And I'm going to use this one again because it's already solved for x. So I have x equals y, but I now know y is 2 plus 6. Sometimes it's helpful to use parentheses when you substitute things in 2. It makes it easy to see where the substitution occurred, and then if there's any distribution or things like that that you need to take care of. So this one's pretty straightforward. 2 plus 6 is 8. So the solution to this system, the point of intersection, would be 8, 2. 8 for the x, 2 for the y. Let's give number 3 a try. So again, I already see that y is equal to 2x minus 1. So wherever I see y, I can now replace it with 2x minus 1. So I have 2x plus 3 times y, but y is 2x minus 1. So you can see on this one how that helps us identify the distribution that needs to occur. So 6x and then minus 3. And we'll go ahead and just do a little cleanup here. Combine your like terms. 2x's and 6x's is 8x's. I'm going to go ahead and add 3 to both sides. So 8x is now equal to, looks like 4, negative 4. And then I divide each by 8. And x equals negative 1/2. So now I'm going to take that. I'm going to go ahead and substitute that right in there for that x. So y equals 2 times x, but I know that x is negative 1/2 minus 1. So 2 times negative 1/2, or 2 negative 1/2 is negative 1 minus the 1. So y equals negative 2. And your solution to this system then is negative 1/2, negative 2. Okay, let's try a couple more. So again, this one's already set. Y equals this. So I'm going to go ahead and replace that in there for y. So I have 6 times x minus 2 times y. But I'm going to replace y with 3x plus 1 equals negative 2. I'm going to go ahead and distribute. Watch your sign out here. So that's 6x's. Negative 2 times 3x is negative 6x. And negative 2 times a 1 is negative 2. You can see right here in your combined like terms, your simplifying step, 6x's take away 6x's, they're done. So I get negative 2 equals negative 2. And at that point, you should notice that that is a true statement, right? Negative 2 is indeed equal to true. So just like when you had a statement like this in prior sections, these have infinitely many solutions. Okay, now I'm going to go ahead and work this one out to solve for y equals. You should kind of have a thought as to what it's going to look like, just like when we graphed in the last section, right? And we had those same equations, those coinciding lines that had infinitely solutions. I'm suspecting that when I rearrange the second equation, it is going to fall to 3x plus 1. But let's do it real quick to verify. So I'm going to go ahead and subtract those 6x's, move it over here. So I get negative 2y equals negative 6x minus 2. I divide by negative 2. I get y equals, that's going to flip back positive 3x, and that's going to be plus 1. And indeed we do. You see that's the exact same equation up there. So just like in section 4.1, if I were to graph these, they are the same line. And I work them out algebraically using the substitution method. I see that I reach a truth here, which also indicates infinitely many solutions. Okay, so let's look at number 5. So this one's already solved for y. I'm going to go ahead and sub it in there. So I get 5x. Clean that up a little bit for you. 5x minus y, but I'm substituting. This is where your parentheses are going to help you again, because I'm substituting in the quantity of 5x minus 4. And so I want to make sure I get this negative, the subtraction symbol distributed through. Because that's going to flip my sign on that 4 right there. So little cleanup, I'm going to combine those like terms. So that's going to be 0, so I get positive 4 equals negative 4. And that is false, which means there are no solutions. And again, if you take this back to 4.1 graphing, I'm going to rearrange this real quick. I'm going to bring those 5x's over. So I have negative y equals negative 5x minus 4. So I'm doing this first one up here. Okay, then I flip my sign, so I divide everything by a -1. So I get y equals 5x plus 4. So if I compare this to this one, we'll see that they have the same slope. They are parallel, but they have different intercepts. So these are just two parallel lines that will never cross. And we see when we worked it out, we got no solution. Okay, let's take a look at 6 and 7. A couple more examples. We're going to go ahead and take this, since it's already solved, and sub it in for the y. So I have x plus y, but I'm going to replace it with -x plus 5 equals -4. So nothing here to distribute, so I can just combine x minus x, positive 5. That makes 5 equals -4. So again, this is going to be false. No solution. So there's no point at which these two will hold the same value. I cannot put something in for x and get the same thing for y. So they are not equivalent at any point. And looking at 7. So again, I'll take my y right here and I'll sub it in down there. Take this and replace it right there. So I have 2 times x plus my -2x plus 5. That's equal to 5. Again, nothing to distribute through, just the positive symbol. So 2x plus minus x, or excuse me, 2x's, so that's just minus 2x. I combine those like terms and I get 5 equals 5. That again is true. So we have infinitely many. And one more time, I just want you to be sure. So if I rearrange this to slope-intercept, I subtract those two x's, and I get y equals -2x plus 5. Again, same thing I have right there. These are the same equation. That is why they have infinitely many solutions. Same thing we saw graphically. Okay, let's take a look at a story problem here. So Nate starts a lawn mowing business. In his business, he has expenses and revenue. His expenses are the cost of the mower and the gas, and his revenue is $25 per lawn. At which point will Nate's revenue exceed his expenses? So let's go ahead and model this. So we got a couple equations. So he's got two things going on. He's got a cost and a revenue. So let's go ahead and write those. So he's got a cost or expenses. And his costs are what? Let's see. He's got a lawnmower that costs $200 and $200 per. There's one of our trigger words there again, rate of change. So his cost is equal to $2 per lawn. We'll just call that X. And the $200 lawnmower. Okay. And then he's got some sort of income coming in. So revenue. And his revenue could be modeled at the $25 per lawn. Okay, he doesn't have any other startup capital or any other additional revenue. So he's going to make $25 per lawn, and he had these expenses or this cost of $2 per lawn of gasoline and $200 for the lawnmower. So essentially what we want to know is, when does this overtake that, so that we can understand how many lawns do we need to mow before we can make some money. So these ones are both solved for y, so really I can just set them equal to each other. I can replace the y here with that, or the y here with that. So I get 25x is equal to 2x plus 200. When will they be equal? That's what we're looking for. So I'm going to go ahead and subtract my 2x's. That's going to give me 23x. That's equal to 200. And then I just divide by 23. So that will be and 200 over 23 is we'll say 8.7. So that's 8.7 lawns. So at what point is he actually making money? After he's mowed 9 lawns, right? Because you can mow 8.7, but you're making money once you've finished that 9th lawn. So we'll say Nate will start making a profit after mowing 9 lawns. Okay, and then you could substitute 9 in to see what that will be at. So we could do that real quick. 25 times 9. So what do we got? 25 times 9. So if we think of that, that's 225. Okay, so at $225, he's going to be able to pay off the lawnmower. He's paid for the gas for each of those 9 lawns, and then he's going to start making money. Okay, let's take a look at another story problem down below here. Okay, so in this example, we're at the amusement park and we've got admission. So it looks like we got 2 different equations coming down here. I've got a $12.50 admission and $75 per ride. And then I've got another one that's $18.50 for admission and 50 cents per ride. So 2 different parks, 2 different equations. So we'll say, let's see, fun time, amusement park. They are, or we can model them at 75 cents per ride. Again, notice those words. That's identifying my rate of change, my slope. And I have an initial cost, a starting point of $12.50. And then the second point, River's Edge, I can model that. Looks like it's 50 cents per ride. There's my rate of change. And the initial is starting cost of $18.50. Okay, so again, we're just going to set these 2 equal to each other. And we want to know at what point, how many rides do I need so that they are the same cost, and when does one become cheaper than the other. So you can see you have a lower initial cost here, but greater cost per ride, higher initial cost, lower cost per ride. So these are pretty standard systems problems. We're trying to determine when it becomes to your advantage. How many rides do you need to ride before this park is cheaper, since you're going to pay $6 more to enter? And if you were only going to ride a couple rides, then Funtime Amusement Park's going to be the cheaper option. So when do you see value here? How many rides do you have to ride before River's Edge actually becomes the cheaper park to go to? So we're going to go ahead and bring these together. So we'll subtract 0.5x. And we'll rewrite. So we've got $18.50. And that's equal to, over here now we've got 25 cents. Subtract that $12.50. And we've got, looks like 6. We'll divide. Okay, I've got 6 divided by 0.25. Again, you can grab a calculator for that, but think about it in terms of money. We're saying I've got $6. How many quarters are in $6? So, well, it's 4 for every 1, so that's going to be $24. Okay, so then it's going to take 24 rides before River's Edge is going to become the cheaper park. So the question they asked, for what number of rides is the cost the same at both parks? And that answer is 24. Okay, look down to the last one, number 10. Give it a try. You can pause the video, then come back and check. So we have part of a weekend job. Aisha went to the snack hut to pick up snacks and drinks for her fellow workers. She purchased a total of 19 items and paid $64.25. How many snacks and how many juices did she get? Well, let's see. So she bought 19 items and paid $64.25. And then we've got snacks and juices. So let's go ahead and call these X's and these ones Y's. Doesn't really matter. And we know that some combination of X and Y, the number I bought, equaled 19 items. Okay, so I bought some X's, some number of Y's, and the total was 19. And then I know something about how they relate in terms of the expenses. I know that $4.75 for each X, I'm getting that from here, combined with the $1.50 for every Y, that's coming from right there. And then I have a relationship, I spent $64.25. So I've found two different equations using the variables X's and Y in order to model this situation. So now I can use my method of substitution in order to solve. So two variables, I needed two equations in order to solve them, and I've got that now. I'm going to go ahead and solve this for Y, so I'm going to rewrite it. So that's just simply removing that X, subtracting it from each side. So if I rewrite this, it becomes Y equals, I'll write it down below here, Y equals negative X plus 19. Okay, so I just rearrange this top equation. I'm going to go ahead and I'll leave it there, but understand that's what I've done. So now I'm going to take this quantity and I'm going to substitute it for the Y value right there. So we'll rewrite that. So I have 475 times X plus 150 times Y, but Y is negative X plus 9. And that all equals 64.25. Okay, so we got a little work to do, so we'll go ahead and distribute that through. So I got 475x minus 150x, and then 150 times 9, so that's going to be 9, and then another 450, so that's 1350. And that equals 64.25. Move this up a little bit for you. And we're going to go ahead and bring these together. So 475 minus 150, that's going to be 3.25. I'm going to go ahead, same move, I'm going to subtract 1350. So I subtract 1350. So that 325x is equal to, let's see, yeah, we'll just grab the calculator on that one. 64.25 minus 1350, and I've got 50.75. And if I want to solve, we just divide by 325. And 50.75 divided by 3.25, 325, equals 15.62. And we'll just round it to the 10th, 15.6. Okay, so as soon as we get that, we should know something's kind of off. Looking here, the math looks good, but what I noticed when I came to that 15.6 and we're talking about the number of snacks, that seems very odd, right? To have 0.6 snacks, should have worked out to a nice number. And as I look back through here, what happened is it equaled 19, and when I wrote it down right here, I dropped that 1, and so I dropped it here as well. So apologize, let's go ahead and back this up a little bit. I need to come back up to, let's take it right back here to this step, and this should be 19. So we'll make that correction here. So I got that $1.50 times 19, 150 times 19 is 28.50 equals 64.25. Okay, so let's go ahead and combine those back again. So 475 minus 150, that's going to be 325. And then we subtract the 2850. Let's make sure we don't make another error here. So I have 64 1/4 minus 2850. And that's 3575. And then we divide each side by 3 1/4. And that looks a little better. And x equals 11. So then if x equals 11, we know that y should equal 8 because they bought a total of 19. Okay, so then you could sub it back in there. So 11 plus y equals 19. Subtract. So we know that the solution, or the intersection, is 11, 8. So what does that really mean? It's 11 snacks and 8 juices. Okay. Bring any questions tomorrow and we'll get some more practice.